This is a Math 2 lesson summary video for the lesson entitled Photocopy Faux. The purpose of Lesson 1 in Unit 7 is to develop a description of the key features of a dilation. The vocabulary you'll want to know is the definition of a dilation, which is transforming a figure by shrinking or enlarging it.
In Unit 7, Lesson 1, I'm going to demonstrate here how we use the rubber band stretcher in order to create a dilated figure. So I've just drawn a basic heart and I've put a focal point, and I'd like to dilate this heart using this as the center of dilation. So how we did this is we take our rubber band, we have two rubber bands, and we've tied a knot to connect them, and you need rubber bands of the same size. So I'm going to put my finger on one end of the rubber band here, hold it down, and I'm going to actually put a pencil on the other end of my rubber band. So now what I'm going to do is, do you see where my knot is? I'm going to trace this heart, and it should create a larger heart above. So notice I'm only looking right now at that little heart that was already drawn, and I'm outlining it, and I am creating a larger heart above. So this is an example of a simpler dilation, and then in Lesson 1 we are looking at dilating a figure of a grandfather, so a portrait of an individual.
So now that you know how to use a rubber band stretcher, we are given the scenario in Lesson 1 of Unit 7 that Burnell has a new job at a copy center and he's helping people to photocopy. And Mr. and Mrs. Donahue are making a scrapbook for their grandfather's 75th birthday party. And they want to enlarge a sketch of their grandfather, which we can see here at the top right of the page. So they told Burnell that they would like the sketch of the grandfather to be in the center. Well, when Burnell enlarges the figure, it ends up looking like this. So we can see that Burnell did not actually put the sketch of the grandfather in the center. So something is off about this enlargement. Going back on up, Mr. and Mrs. Donahue did say that they wanted the image to be twice as big. Okay, so now we need to figure out what exactly happened. So on the next page, we're asked to look at the diagram below, and the first question tells us to explain how the photocopy machine produced the partial copy of the original image. So in class, we did use the rubber band sketchers. We each had them. But we also did take a look at a GeoGebra example of this portrait. So as you can see, this is a digital image of my rubber band. So here's my fixed point, here's where I'm going to trace, and here's my end point. So the first question is asking us, how did this happen? How did the image end up in the bottom right corner? So if we take a look and we put that middle rubber band, let's say on his nose, the focal point, the fixed point up in the top right corner, we see that this actually is a perfect dilation of that point on his nose. So what happened was Burnell must have taken the portrait of the grandfather and put it in the top right corner so that the top right corner was fixed here on the photocopy machine. So that's not actually what Mr. and Mrs. Donahue were looking for. Number 2 says, using a rubber band stretcher, finish the rest of the enlarged sketch. So we can use technology or we can use the hands-on rubber bands. I'm going to go back to my technology. And so what I'm going to do is I'm going to watch, just like I did with the heart, I'm going to watch this point. I'm going to trace starting with this point. So I'm first going to trace just the outline of the portrait so that I have a rectangle. And remember, this is a sketch. I am using my keyboard So it's not as easy to use as the piece of paper that we have in class. And you can see there's my sketch. And I'll stop tracing so I can move it over here to the middle of his head. And I will trace again. So you can see that I'm watching that number 1. I'm watching that 1, that middle point right here, and I'm tracing it over here. So then we can also outline his body. I'll just do a little bit of his body. If I start here, well, let's start where we left off on his head, I guess. Maybe right there. And I'll just do a little bit of that. So we can see that this is actually the dilation that Bernal performed. And that's why it ended up not being in the center of the paper. Okay, so I'm going to stop moving that just so you can see. And this is exactly what we did in class. So we actually sketched it and we dilated it just like I did here on the technology for you. So in number 4, we are asked if Bernal doubled the image or quadrupled it. Well, we can find the area of my original figure by multiplying the length by the width, which we can measure with our ruler, and we can do the same with our final image. We can see that it's 4 times bigger. However, if we measure from the nose of the original figure to the nose of the final figure, we actually see that those line segments are 2 times bigger. So if we take any pre-image to an image point, we will see that they're 2 times bigger. Some main takeaways from this lesson. It is quite short, but the main takeaways about a dilation are: you need to know the center of dilation and your scale factor. Scale factor is what are you doubling by? That means multiplying by 2. Are you tripling it? Are you multiplying by 4? Are you shrinking the image? Are you dividing by 4? Are you dividing by 2? Or multiplying by a half, etc. Corresponding pre-image and image points are located along lines that pass through the center of dilation. The distance from the center of dilation to a point on the final image is k times the distance from the center of dilation to the corresponding pre-image point. For example, if I measure a line segment in the pre-image, AB, and the scale factor k is 2, then my final image should have a length of 2 times the original length, or 2 times AB. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.